Hello everyone. So, now we have reached probably the most complicated problem in today's lesson. So it states that the center of a regular polygon is the point inside the regular polygon that is equidistant from all of the vertices of the polygon. Let the distance from the center to one of the sides be k, and the length of each side of our n-gon be s. Find a formula for the area of an n-gon in terms of k and an s. Okay? So each side length az is s all the way around because it's a regular polygon. Now, for this diagram obviously has a finite amount of sides, but for the sake of our argument, let's assume that this process could work for any amount of sides n. Imagine there's just infinitely many sides in this polygon. You obviously can't physically draw that. That's why we have this limited figure to try to help us visualize what's going on. So, in our problem, we have that the length from the center to the side of one of the side, like AZ for instance, that's going to be what we call K. From the center to one of the sides. Now it mentions that the center of a polygon is called the center because it's equidistant from the vertices. So let's draw the lengths from the center to the vertices. Now again, we have that this length SO is K, and this line here is perpendicular, and these side lengths are the same because by definition the center is equidistant from the vertices, which means that this triangle is isosceles. So these angles are the same, and each point here, so I'm gonna erase some of it. The point here is gonna cut AZ in half. So for instance, if I call this point M, we have that AM is half of S. Now how can that help me out? Well, if I find the area of this triangle, it might help me find the formula that I'm looking for. Because if each triangle is being made with a side AZ of the polygon, then that means each polygon can be cut up into n amounts of triangles, since each triangle has a base of one of the side lengths. So let's try to find the area of AZO, which means I have to figure out what K is. Well, since our formula is just in terms of K, we can just kind of keep it the same. So we have that the area of AZO is 1/2 base, which is AZ, which is S, times the height K. Now again, in our polygon, since each triangle is being made out of a side length of that polygon, and we're assuming that there's n amounts of sides, that means to find the area of the polygon, area of polygon, P, I have to multiply it by the amount of triangles in the diagram, and I would have n amounts of triangles. If you think back to the previous problems, like when we did a hexagon, there were 6 triangles in a hexagon because there's 6 sides, and therefore an n-gon has n triangles in it. So I have to take this area here and multiply it by n. So we have n times 1/2 times s times k. And simplifying that, we can write it in the following way. N times s times k over 2, or 1/2. And that is our formula for the area. It's the number of sides times the length of each side times the distance from the center to one of the sides. And sometimes this distance k is referred to as the apothem of a shape. The apothem means the distance from the center to a side, but it doesn't really matter. All we need to know is that for any regular polygon, the area can be found by multiplying the number of sides times the length of each side times the length from the center to the side, and divide that in half. And this becomes a general formula that works for any regular polygon. Half its perimeter times the distance from the center of a polygon to its side. Well, now you might be thinking, how is it half the perimeter? Well, because the number of sides times the length of the sides is the same thing as the perimeter. N times S equals perimeter. Think about it. Since n is the number of sides times the length, think about it with simpler shapes. If I have a triangle, an equilateral triangle, what's the perimeter? It's the length of all the sides times 3. What's the area or the perimeter of a square? It's the number of side, the length of the side times 4. So because we can assume that each side length is the same, each side length is s, so the perimeter is s plus s plus s plus s plus s, or just s times the number of sides. So we can simplify this formula even further to p times k over 2. And again, this formula works for any regular polygon.